Hello, this is Ms. Pettigrew, and today we're going to take a look at what is the difference between an irrational number and a rational number. We're also going to take a look at, can a number be both irrational and rational? We've talked previously about what a rational number is, and you should recall that a rational number is a number that can be written as a fraction. It includes both terminating and repeating decimals. And so today we're going to focus on what an irrational number is. Alright, so today we have quite a bit of vocabulary that you need to get into your notes. We're going to start with a perfect square. We're going to move into a square root, an irrational number, which is the focus of today's lesson. And then we're going to take a look at rational square roots and irrational square roots.
A number that is the square of an integer is a perfect square. The square root of a number is another number that, when multiplied by itself, is equal to the original number. Some square roots are rational numbers and some are irrational numbers. Irrational numbers are numbers that cannot be written in the form a divided by b, where a and b are integers and b does not equal 0.
Okay, so you should be realizing at this point that irrational numbers are numbers that cannot be written as a fraction. Notice the ir, meaning not, so they're not rational, so they would be the opposite of a rational number. Okay, so there are two different types of square roots that we're going to focus on today as well. The first type is going to be rational square roots.
A number a is a square root of a number b if a squared equals b. For any whole number b that is a perfect square, the square root of b is rational.
Okay, you want to make sure that you're getting these definitions into your notes. So what this is saying is that a number like 4 would be a rational square root because you can multiply 2 times 2, or 2 squared, to get 4. Therefore, the square root of 4 would be 2. Another example would be 9. Again, you can do 3 times 3, or 3 squared, to get 9, so the square root of 9 would be 3. And those would be examples of rational square roots. The next type of square root we want to talk about is irrational square roots.
A number a is a square root of a number b if a squared equals b. For any whole number b that is not a perfect square, the square root of b is irrational.
So for irrational square roots, if the number underneath the radical sign, and the radical sign is this little check mark looking thing right here, we call that a radical sign. If the number underneath the radical sign is not a perfect square, for example 5, there is not a number that we can multiply by itself to get 5. So the square root of 5 would have to be irrational. Okay, let's go ahead and take a look at some examples together. We want to
determine if each square root is rational or irrational.
Alright, so we have the square root of 2. The square root of 2, is there a number you can multiply by itself to get 2? If you say yes, then this would be rational. If you say no, then it would be irrational. Hopefully you're thinking it's irrational. The square root of 6, is there a number that you can multiply by itself to get 6, or a number that you can square to get 6? In other words, is this number under the radical a perfect square? If your answer is yes, you would move it to rational. If your answer is no, you would move it to irrational. Again, hopefully you're saying no. 6 is not a perfect square, so the square root of 6 would be irrational. Square root of 8, again, is not a perfect square, so it's irrational. Square root of 4. Square root of 4 is 2, because 2 times 2 is 4. So this one would be rational. Square root of 9 is 3, so yes, it's rational. The square root of 3, is 3 a perfect square? No, so it's irrational. Is 7 a perfect square? No, so the square root of 7 is irrational. Is 5 a perfect square? No, so the square root of 5 is irrational. Let's check them, and good. We got them all correct. Alright, here's a similar exercise. I want you to answer this one on your own.
Which numbers are irrational?
At this point, you might want to pause the video while you figure out which ones are irrational, and then you can unpause it to check your answer.
Harry, what were you thinking trying to memorize all the digits in pi? It doesn't terminate, it doesn't repeat, and there's no pattern. Rational numbers have decimal expansions that terminate in zeros or eventually repeat. Irrational numbers cannot be represented as terminating or repeating decimals. Irrational numbers also include non-repeating decimals that have a pattern in their digits. Since pi is an irrational number, the decimal digits do not terminate or repeat.
So your example, the square root of 10 is an irrational number, because if you look at the decimal expansion here, it continues on and on and on without a pattern, and it does not terminate. If you'll look here, this decimal is also irrational. It does not have a specific pattern that continues through the entire expansion, so therefore it is irrational. Alright, let's go ahead and take a look at this example.
Determine if each number is irrational or rational. Assume each pattern continues.
Okay, so 2 and 125 thousandths. Notice there's no dot 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 at the end, so it does terminate or stop, and we remember from the other day terminating decimals are rational. Look at example B. Notice that the 1 keeps repeating on and on and on forever. We also talked about rational numbers also being repeating decimals. So, example B, 2 and 1/10 repeating would also be rational. Let's take a look at C. This is that example that we just went over. 2.01, 011, 0111, 011111. It doesn't have a continuous pattern, so that one's going to be irrational. And look at this one, 2.1234, 1234, dot dot dot. That means that it is going to continue repeating 1234, 1234, 1234. So if it's a repeating decimal, we know that to be rational. And let's look at this one. We have 1 and 8.033333. So the dot 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 means that it is going to continue the 3. So that does make this a repeating decimal. So it's also rational. Go ahead and check. And yes, we got them all correct. Okay, you're going to want to try this one on your own again.
Which number is not irrational? Assume each pattern continues.
Again, pause the video, and then once you figure out your answer, you can play it again to reveal the answer. Okay, so this short video is going to review for you the real number system that we went over the other day, adding in the part that we're talking about today, which is irrational numbers.
The first set of numbers you learned about was the natural numbers. These are also called the counting numbers. The natural numbers, together with the number 0, form the whole numbers. So all natural numbers are also whole numbers. The integers are the set of positive whole numbers, their opposites, and 0. So all the whole numbers and the natural numbers are integers. The rational numbers are the set of all numbers that can be written in the form a divided by b, where a and b are integers and b is not equal to 0. So all integers, whole numbers, and natural numbers are also rational numbers. And irrational numbers are numbers that cannot be written in the form a divided by b, where a and b are integers and b is not equal to 0. Together, the rational and irrational numbers form the set of real numbers.
Right, and notice that our irrational numbers are out here. They're not inside the boxes with natural, whole, integer, and rational, because there's no way they could be rational and irrational at the same time. Okay, but they are part of the real number system. And you want to make sure that you add these irrational numbers to your diagram that we made the other day. So turn back into the first set of notes that we took, which was in class, and add irrational numbers as an example, and then you can box it in and call it the real number system. Okay, so let's classify a few numbers.
Indicate all of the possible names for each number.
We did this the other day. The only difference is today we're going to add in the irrational numbers and our real numbers. Let's start with the number 15. You should be thinking of 15 as a counting number. So since it is a counting number, it's natural. Therefore, it's going to be in every category except irrational. Because if something is rational, it cannot be irrational. Remember, that's why we put it on the outside of all the other boxes. Okay, look at the next number. -1 and 232 thousandths. This is a terminating decimal. So since it's a decimal, it's rational only. And if it's rational, then it's also a real number. The square root of 45. You need to be asking yourself, is this a perfect square number, 45? If you say yes, then it's rational. If you say no, then it's irrational. Hopefully, you're thinking there's nothing I can multiply by itself or square to get 45. So that's going to be, it's not going to be a perfect square. So therefore, it's going to be an irrational number. Alright, the next number, 121 over 35. 121 over 35 is written as a fraction. All numbers that are written as a fraction are automatically what? Rational. Okay. Then your next number, this is the negative square root of 16. Well, is 16 a perfect square? Is there a number that you can multiply by itself or a number you can square to get 16? Yes, there is. It's 4. And the negative is on the outside of this radical, so that means it's really going to be -4. So you should be asking yourself, what is -4? What category does -4 fit into? Hopefully you're saying integers, and therefore if it's an integer, it's also rational, and it's real. And then the last one, 21 divided by 3, or 21 thirds, that is equal to 7. So even though it's written as a fraction, which we think is rational, you need to simplify it first, and since it's 7, that is what kind of number? You should be thinking natural, or a counting number, so it falls into every category except for irrational. Alright, you want to try this one on your own?
What are all of the possible names for 1 and 2/9?
Again, pause the video, figure it out, and then replay to show the answer. Alright, this brings us to the end of our lesson for today. You want to make sure you do all of the closing check. You need to answer your focus question. What is the difference between an irrational number and a rational number? And can a number be both irrational and rational? You should be able to answer both of those questions now that you've viewed this video. You also need to answer questions 1 through 5 and make sure you have those completed for the start of class tomorrow.